All right, so we had asked you to go ahead and get started on this review sheet. Like Mr. D said, the first 6, we were really hoping you knew those off the top of your head already. But if you didn't, you should have looked them up in your packet. The rest of them were worded a little funny, so I do understand if you got stuck on some of those. So let's start with weathering. What is weathering? And one word is good enough if you want to use just one word. Breaking. What did you? Okay, breaking into sediments. Perfect. Then what's chemical weathering? It does. The only thing I want to make sure that you still understand with that is it is still weathering. It is still breaking down the rocks by changing the chemical composition. So those rocks are still getting changed and broken down, but they're doing it this time by changing their composition, just like rust on a car. When you've got that rust on a car, it is breaking down the metal, even though it's not just hitting it with a hammer. Whereas the next one is physical weathering. How did you define physical weathering, Brooklyn? Yep, and that's basically what I included there, except I did include again that first sentence. It's still weathering, so it's still breaking down of the rocks into smaller pieces. You could add, if you didn't, like I didn't, just a reminder, like Brooklyn says, does not change composition. Now you can see over here the differences that I included. So I figured a T-chart was the best way to do it. A lot of people always just say one changes the composition. Make sure you always include which one changes the composition. So I did include that. Chemical changes the composition, physical does not. And then I do think it's important to remember the climates that are best for each. So chemical is warm and moist, and physical is cold and moist. Questions so far? All right, then we're going to go on to erosion. Phoenix, what's erosion? You can use what? Yeah, sediments moving. I use the word transportation of sediments. Any word that means moving is good for that. And then the 5 agents of erosion. Remember, you've got your hand. There's the 3 W's, water, wave, so running water, waves, and wind. And then the 2 G's, glaciers and gravity. Now, these second set of questions here, they were worded funny. I meant to tell you exactly what I wanted. So rocks that are eroded by gravity are, and then I put in parentheses, look. What do they look like if they're eroded by gravity? Angular. And deposition by gravity, is it sorted or unsorted? Unsorted for gravity. Now give me some key words, phrases, features that are created by gravity. That's what I was looking for here. By talus slope is one thing. Talus slope, sorry guys. Mudslide. Avalanche. I think it ends in an E, doesn't it? Creep was another one we learned. But mostly for gravity, it is most important that you remember they are unsorted. For the most part, that's all they really ask about for gravity erosion. Or they might give you a picture of gravity erosion like a landslide and say, what was the main cause of these sediments flowing downhill? And hopefully you remember it's gravity. You know what? We haven't done waves yet. So I'm assuming you left this box blank. Okay, that's good. We're going to keep it blank for right now. Probably tomorrow we'll fill it in. Let's move down here to glaciers. So sorted or unsorted? Unsorted. Again, uber important that you know the 2 G's are unsorted. What are some features that glaciers create? We have talked about this like a gazillion times. Give me one. Striations. Guys, if you don't have striations in this box, I highly recommend you add it. What's another thing? Abso-freaking-lutely. U-shaped valleys. I think those are the two they ask the most about. Anybody have another one? Okay, the other ones that they sometimes bring up are moraines, drumlins, and then the Great Lakes, the Finger Lakes, and the Kettle Lakes. So I'm just gonna say Kettle, Great, and Finger Lakes. Again, is it super important you remember what each one of those things are? No, but as soon as you hear about a moraine or a drumlin, I want your brain thinking, oh yeah, glaciers made those. I know that. Deposition by wind, sorted or unsorted? Absolutely. And what do they create? Give me a list. Sand dunes. Yep. Abrasion, and with abrasion is sandblasting. And mushroom rocks. Again, I do think it's most important that you remember that those are sorted. So again, it's super easy to remember. The 2 Gs are the only unsorted. Everybody else, the 3 Ws, they're all sorted. Everybody good on this side? Again, we skipped waves until like tomorrow. Here where it says sand dune, let's draw a sand dune. In fact, let's draw 2. Why don't we split this box in half and draw 2 sand dunes? What is a huge feature about a sand dune? There is a lot of sand, and what? The way the wind blows. Which side is the gentle side? Whichever way the wind is. So I'm going to draw 1 right here. I'm going to draw, nope, that's not going to work the way I drew it. So I've got a gentle side, and that's the wind side. So I guess I got to draw a smaller one here. It's going to be a gentle and a steep side. I don't know why I cut the box in half diagonally. That was weird. So the gentle side is the wind side. I'm going to just put a little note. Yeah, here, let me show you that one to make sure your pictures look the right way. So you should have a long, gentle side and a steep side. That's going to be the wind. And then you're going to have the opposite of that. So the wind is always on the gentle side. Couple things for running water. What are some things running water or rivers create? First of all, they create V-shaped valleys. What are a couple other things that we've mentioned about running water?
Oh, they create those,
What shape are they?
triangle, right?
Triangle shapes. What are they called? They're not. No, but that is another word. No, but that's another word. It starts with a D, right? Well, that too, but that's not what Phoenix is talking about. Come on, guys, help them out. Start with a D. They look like triangles. Where are they? Right at the end of it, right? Deltas. Deltas. Meanders. We had floodplains. Okay, no, focus on earth science. Then I can't do it either. You can give me a lesson at the end of class because I've always wanted to know how to do it. You can't do it. Okay. Sediments deposited are This one's been yours. You've been doing it out for all of them, sorted or unsorted for running water.
Oh, unsorted.
No, that's not it.
Sorted,
Okay, so how should we remember?
by the waves.
The way I remember is it's one of the W's. Water is one of the W's. They're all sorted. Let's skip this box till we go over our homework because it's right in the same thing. So let's go to this one. On the outside of a meander, the water is moving fast. And because of this, because it's moving faster, there's more erosion. And because of this, the stream is blank on the outside of the meander. We're talking about a curve. So what do we know about, yeah, it's going with deeper. So but you're right, because it's moving faster, that's why that's what's happening there. This is something you gotta remember, because then it's gonna help you when you get to an actual picture of this. So then this is the opposite. The inside of a meander, the water is moving slower. Because of this, so because it's moving slower, there is more deposition. And because of this, so because there's more deposition, the stream is, yes, shallower, if that is a word. We've already discussed that.
Yeah.
I don't really care. It works, doesn't it? You all know what I mean, even if it's not a word.
Yeah.
I got it. Is more, yeah, is shallow. Yeah, is shallow would work. Is shallow. Nice, genius.
Wait,
That is a
Wait, can't you just use the word shallow? I just said, so we just said.
not quite as much of a genius as Alex. All right. Hey, which letter is, name one letter that's an outside of a curve? B. What's another one that's an outside? Look closely. C prime. So that means C is an inside. Same with B prime. What the heck's going on at A? Yeah, that's called straight then. Straight. So we want to draw a profile. Do you guys remember doing this? It was Thursday, I believe. So we drew the shape of the bottom. This is when Phoenix went wading in our river. Okay, so A is a straightaway. Yep. Where's the deepest spot in a straightaway? Dead smack center. So put a dot in the dead smack center. At the bottom, we're showing it's the deepest. So the dead smack, never mind. I can't, sounding funny. Connect them up. So it should look like a perfect V shape. But B is a curve. We already said that B is the outside, B prime is the inside. So in this case, I'm going to go ahead and label this B and B prime. Always look at the labels. This time I just added one. When we have a curve, which one's the deepest? B, because it's the outside. So again, you put that dot close to B, but not right on top of B. And, whoa, I missed my dot, but you get the point. Make my dot bigger. There we go.
So the outsides are always bigger. Deeper.
Deeper. The outside is always the deepest. So that's why if you notice here, I had you label them first. So then you don't have to think about it when you go to draw them. And then finally, C is another curve. So again, we'll do C to C prime. Which one's the outside again? C prime. So which one's the deepest? Phoenix, which one's the deepest? C or C prime? Phoenix, take a look at that picture again. C prime. Put a dot. Dot by C, by C prime, not right on top of it, but close. And connect them up. All right, we skipped this box because this is what we gotta go over for our homework real quick. This is page 7, not yet. I'm not ready to learn yet. Okay, this page right here on page 7 of your reference table. I lied, it's page 6 of your reference table. You do have the bigger version in your packet. I'm gonna pull that one up just because it's a little easier to read, the bigger one. The bigger one's on page 29 of your packet. So you can either use the one in your reference table, which you do have to get used to using. Perf. Go ahead and answer that question now. So why doesn't everybody go ahead and take a moment? How fast does the stream have to be moving to be able to carry a sediment that is 0.1 centimeters in diameter? Then the second question is slightly different. So take a minute, take a second or two, I should say, to figure that one out. So a straight edge might help. No, remember how we said those count by weird numbers.
Oh,
Oh, yeah,
oh.
count. Remember, it's 1 is labeled.
He said 5 and she said no.
Who said no?
You, didn't you?
I was talking to you, dude.
Oh.
No, Sam was right. All right, so the problem Phoenix just encountered. So we said 0.1. So one thing that a lot of people gotta be careful about is the question says, how fast does the stream have to be moving to carry a sediment that is 0.1 centimeters in diameter? There are 2 0.1s, which will give you 2 very different answers. So make sure you use the 0.1 that they asked about, 0.1 centimeters in diameter. Go to hit the black line. Go down. Here's where I like to use that straight edge. Or you won't have a ruler, you'll have a scrap paper. So I'm using this ruler because it's nice that it's see-through. Because you just don't. Yeah. The good news is you don't have to measure anything. You will need the scrap paper for doing math anyway. And the scrap paper stuff we do for earthquakes and for profiles, you'll need to have that there during the regions anyway. Yeah, of course. No. Are you serious? What? All right. Anyway, right here is where that hits. It's also, guys, stay focused. It's really hard because of the way the numbers go. Keep in mind that 1 is here, 2, 3, 4, 5. So I got exactly 5 centimeters per second. Then the next question goes the other way around. What's the largest size sediments a stream flowing at 10 centimeters per second can carry? So I go from the 10 centimeters per second up till you hit the dot. And how nice is that that's already labeled as 0.2? I know, like, right? 0.2 centimeters. Darn. That is your review sheet minus the one thing we have to learn tomorrow. Your test for this is not going to be until at least Thursday, maybe even Friday. We'll let you know tomorrow, but expect it this week, either Thursday or Friday. Okay? You had homework?
Okay, I did that.
Good.
I'm dinner. You're lying. Oh, yeah? Yeah.
So we had already done 2 of them. Now the next one, funny, we just answered that exact question. Hopefully you had this as 0.2 centimeters. Number 4, 0.3 centimeters per second. Here's 0.1, 0.2, 0.3, right there. Ah, also a nice easy one, 0.006. Then they switched them to going the, what?
I got 0.005. So, I mean, she doesn't like being followed, of course she did. Oh,
Let me. Did you not see that it was nice and labeled though? No. So be more careful, but probably okay. Stream velocity, we got a sediment that is 10 centimeters. We want to know how fast it's got to be going. Right there, it looks like it's hitting on 200 centimeters per second. And again, funny enough, I believe we already did this one in our notes. This should be 5 centimeters.
that's ironic, we did it in our notes. And I didn't know.
That's weird, right?
That's very, what a coincidence.
Coinky dink. And this last one, I never talked about it. It's kind of stuff I kind of hoped you got from real life. How much energy is needed to start a particle moving in a stream? And the answers are either more than is required to keep it going, less than is required to keep it going, or the same amount as required to keep it going. What do you think? So let's do a real life, imagine this situation. You guys ever have to push a car, a four-wheeler, a lawnmower, not a lawnmower, but like a tractor, out of the way of some, like you had to push it? Ever push a car?
Yeah.
Yeah? I mean, as long as it's in neutral, it's totally doable. What's harder, getting it going or keeping it going, or is it the same? Like you got to use the same muscles throughout the whole thing. Getting it going takes a lot more energy than to keep it going, doesn't it? So keep it. Darn it, Drake. Yes, you're right. But we are assuming it's either flat or in this case, since it's a stream, it's probably going downhill-ish at least. So what do you think? Does it require more or less or the same amount of energy to get a piece of something going in a stream? More. It's just like moving a car. So it requires just a little bit more. And notice the reason I bring this up is because of this little jumble of words right here. This is a generalized graph that shows the water velocity needed to maintain, but not starting movement, but not to start movement. So it will take a little bit more to get it going, just like moving a car. All right, so that did take a little bit longer than I had anticipated. You do have homework tonight. It is pages 21 through 23, which sounds like a lot, but if you, there are 5 questions on 21, 2 questions on 22, and 4 questions on 23. So is that 11 questions? You got this. You got 10 minutes to start right now. No, you don't. 5 minutes to start right now.
I'll start.
And then you probably got a couple more then to do at home. So there are only 11. So try. This is good review for the test that's coming up. So again, homework is pages 21 through 23.